Today we have a little bit work at the Powerwall again. I received the BMS, and the second item we will install is a DC contactor, because with the DC contactor we will operate our inverter. Okay, so yesterday I got the BMS, and what I did, I added some extra lengths of leads for the balancing, and I also put crimp connectors there, clears. Yeah, we will take all this, go to the Powerwall and just do the job. Okay, in the meantime I received the BMS. It's a standard BMS, another Chinese manufacturer. It's kind of the same level as Dali. It's a regular type of BMS, common charge and discharge, 70 amps for charge and discharge. In our case we will probably see maximum 40 amps on our Powerwall, so this is a good buffer for the current. It has a temperature sensor, but in this event this does not help anyway. The balance leads I need to extend because our battery pack is quite big. I need about extra half a meter of wire. This I will do now later, and then I make some crimp connections so that we can just screw it onto the bus bars. Yeah, so very normal BMS, no special features, no Bluetooth, that's all I have to say, and we will just build it into the Powerwall tomorrow. So the BMS comes with 4 main wires. 2, these blue ones, will go to the battery minus, and this one is then the load minus. And so I put 2 crimp connectors here, 2 pliers on each of those, and we will just bolt it together with the other cable which comes from the battery. The BMS will stay somewhere in this area, and then we can just route all those balancing leads from the back side of the battery cells to the bus bars. And then we will use one of these bolts here, and we add the balance lead to that. It's fairly simple, but the only thing we need to be careful is, of course, to use the correct order of these balancing leads. If you make a mistake in this one, that's not good. Yeah, so I will do the job and show you how this looks like when it's finished. Okay, the BMS is installed. Let me show you a close look. I put the BMS here on that steel rail, so the steel rail can also take away some heat from the aluminum sink there. You see, every bus bar has one of the balance leads connected. This goes all through the pack like this. Unfortunately, the balance leads on the lowest bars have been a little bit too short to go from the back, so I had to make it from the front side. The system is working, so the BMS is letting the power pass, and in the charger. So today we are going to fully charge up until probably the BMS will cut out a few times, because this kind of BMSs, they don't have good amounts of balancing current, so it will probably hit the cell limit somewhere, then shut down, open again, balance a little bit, etc. So maybe at the end of the day we should reach a higher voltage than last time. Last time we only reached about 56.1, I think, if I remember correctly. So we'll see if today, at the end of the day, the voltage will be somewhere closer to the charger's maximum voltage of 58.4. So I will continue now and install the DC contactor. And for this one, because for the time I need to use a 12 volt power supply to power it, I will also install already a AC outlet here. Okay, I'll be back in a bit. Okay guys, take a look. I not just did the DC contactor here, I also put the controller on its place, but that is not connected yet. It's just to see if we will have space. And I made a AC outlets there for some power supplies, and I cleaned up the build a little bit. Yeah. Now you can see, maybe or not, you see the inverter on the display, it is showing starting voltage too low. Even the breaker for the inverter is now on. This is because the DC contactor is now open. The DC contactor has a 12 volt coil and will later be activated by the controller unit, but for the time we can operate it by plugging in the power supply. So let's do that. So you heard the clicking, and what is the display showing now? Yeah, the display is now showing no more voltage too low, so the voltage is here. It's just the demand on that phase is basically zero. It is showing 27 watts, so the inverter will not activate, but it works. So let's close the breaker here again, and we can continue charging. Open the charger. Today it is a little bit cloudy, but there's power is available, so we can try to fill up the battery. Continue with this. There's no more to see for the time. I will give you a short summary of what needs to be done to finish our project. Right, the build is almost finished. There's a few things still missing. One is the 100 amp main DC breaker, then another DC breaker for the second charger, then the second charger, and the control unit. The hardware is almost complete. I'm waiting for a new rotary encoder switch and a 9 volt power supply. And the software is already set up. It should be operational. So what about the situation about the charger? I told you before that I never saw this charger outputting more than 25 amps. So I had a talk with the seller, and we came to an agreement that there was some kind of mistake made in the factory, and this charger is really a 25 amp charger. So they gave me a discount for the second one. They took off the difference, what was between 25 and 30 amps in price. and reduce the price for the second charger by that amount. But now I had a problem. My plan was that the second charger would be a 20 amp charger, which would not make much sense, because you know, if you have two chargers, you want to have a difference between the two outputs to make a kind of logical system. So I decided that the second charger will be an 18 amp charger. So we have the charging steps: 18 amp, 25 amp, and together 43 amp. It's not what I wanted. It's a little bit less in basically power output of the Powerwall and what we can store during the day probably, but we cannot change it, so it will be the best we can do in this situation. Yeah, the Powerwall is finally looking amazing almost. This is the work what we could do today. We continue charging. We will monitor the outcome of the charge today, and then already kind of discharge in a manual fashion. So thank you for watching. I hope you still find it interesting. There will be more videos. Please like and subscribe, and I see you next time.